adding more bandwidth will solve all the network issues. So what's your take on that?
Yeah, it's really simple. I will start with the show.
Buffer bloat is the undesirable latency that comes from a router or other network equipment buffering too much data.
We're joined by FRANTISEK Borsik to break it down and discuss why it matters.
So can you tell us what exactly is buffer bloat and how can it degrade the network performance?
Excessive latency that's happening in the buffers, not only on the routers, but also in every other networking equipment.
Right, and with regards to how worse the situations can get when with the buffer bloat, can you give us a number of the worst delay that you have seen in a network?
That can be 10 seconds, which is like horrible. It's unbelievable. Even like to have a Zoom call with 200 milliseconds latency, it can be terrible.
Are there any speed test recommendations that you would suggest which highlight the issue of buffer bloat?
Probably the first speed test that really showed buffer bloat as a really important issue on the internet. Waveform, then UCLA speed test that everybody knows, they started to show latency.
So what role does latency have in an end user's experience?
Basically the whole, right? Almost everything what we are doing right now is latency sensitive, it's interactive.
Hey everybody, welcome to Weekly Wi-Fi Wisdom podcast series where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host Sainath. I'm WLAN QA engineer at Candela Technologies, and in today's episode we are joined by FRANTISEK Borsik, and he is currently working as Chief Operating Officer at LibreQoS. And in today's episode he is going to talk about buffer bloat and latency. Thank you so much for joining, Frank. It's a pleasure having you, and I'm really excited and looking forward to talk on buffer bloat today.
Thank you very much for having me, Sainath, and the Candela team. And, if I may start with, we are really thankful, or I'm really thankful personally for everything that you guys did for Dave Taht, my so sadly deceased colleague, that was basically at the very start of this whole fight against buffer bloat, latency, and jitter online worldwide, together with Jim Geddes since 2010. So we are 15 years in, and we still didn't solve this issue. And Candela was nice to support Dave's work in the past. So it's like, for me, this is like a closing of circle. So I'm coming back now to talk about Dave's work and what we are doing from now on. And I'm really thankful for you guys for having me.
Absolutely. And I think we need to take a moment to remind Dave for his significant contributions in eliminating latency across the internet. So he's the co-founder of Bufferbloat Moment, so the bufferbloat.net. And he passed away early this year. So rest in peace, Dave. That. And yes,
thank you very much.
Yeah. Okay. Let's get into the topic. So let me start with an opinion, right? So whenever there is an opinion on the internet, or at least few people who think that adding more bandwidth will solve all the network issues. So what's your take on that?
Yeah, it's really simple. I will start with the show. Bandwidth is a lie. Yes, it's like it's unbelievable that we are still living in 2025 and people still believe that they just need to throw more bandwidth on it, and the solution will, and it will be done. It's not true. It will never be true. Like till the end of time, right? Everybody talking about bandwidth as a solution is wrong. We see it day and night everywhere when we are using Wi-Fi, where we are on 5G, even when we are on satellite internet, fiber, you name it. Even on fiber, it's not the solution. Like you can see so terrible provisioning in hardware in fiber that you will have your gigabit speeds, so-called speeds, right? And a lot of latency, and your Zoom call will suffer. Then, on the other hand, you will have a 10/1 Mbps connection with the right solutions for buffer bloat, latency, and jitter, and your Zoom call will be amazing. You will be able to play online game, and everything will be fantastic. But the gigabit internet right in a flat next to you will be suffering from this crazy issue that is still bothering the internet and the people and the applications using the internet still also in 2025. And we know the cause of the issue, right? The internet, as it started, it was never built for interactive applications. That's the thing.
Right.
The forefathers of internet, they were using email, FTP, and then some websites at the very beginning. But the actually interactive applications, they started in the early 2000s, right, with Skype and like video conferencing, voice over IP,
Right.
and so on. Then first online gaming, first streaming, right? So then like everybody was surprised, like we all were surprised that suddenly there is this excessive buffering happening, and we didn't know till 2010 when Jim Geddes got together with Dave, and he especially Jim coined the term buffer bloat, right? Till then, like we were thinking that it's just the router. There is something wrong with the router, and in fact, or any other hardware, and in fact, there is something wrong with all networking equipment out there, and that's big buffers. There are some companies that are even bragging that they have biggest buffers in the industry. It's so sad. It's so sad to still see people talking about it. But the buffer bloat is a problem. It will be a problem till we will fix it. And the fix for this issue is out there, but is not evenly distributed yet.
Right. So people should not just look at the bandwidth, but we have to look beyond bandwidth, and there are many metrics that we need to look at to ensure a very good user experience.
Absolutely, I agree.
Right. Yeah. So with that, as we are talking about buffer bloat, it is also coined by the founders of the moment. So can you tell us what exactly is buffer bloat, and how can it degrade the network performance?
Right. So you will hear quite a few definitions, and you can approach the buffer bloat as a phenomena from different angles. But it's excessive latency that's happening in the buffers, not only on the routers but also in and every other networking equipment. Like if we would be able to size the buffers properly, then we would for the most part fix the issues. But the problem is it's also connected with packet drop. People would like to see networks that will never drop the packet, but it's impossible. It's really impossible to get it or to set up networks in this way. It's really important signal mechanism that the sender should stop sending in this rate, and they should resend some packets again. So we have ECN marking and other signals that we should observe. And then again, we shouldn't sell big buffers. There is a couple of papers that I will send for the show notes, and talks from amazing people like Van Jacobson that actually really observe in the past, like really maybe 20 years ago, that companies want to sell buffers, right? They want to sell hardware, new hardware every couple of years, new Wi-Fi standards, new 5G new 3GPP standards, and so on. But they want to sell buffers, And that's the issue everywhere. When we are buffering and we are not cleaning buffers as we should, then we are always creating the buffer bloat. And then then there is an additional thing that to add, that people believe that when the bandwidth will be there, so pipe will be really wide, then this will go away. Like, I understand why they are coming to this conclusion, but it's not true, because like you will really have a big fat buffers, and you will be still struggling, right? I will add another example. So we have a different type of flows, and you can basically, or packets rather, and you can use two distinctive examples. It was described in a old tale from the past about mice and elephant. Big flows, downloads, big download, big upload, best effort stuff, email, whatever it is. It's mostly big, right? So it's an elephant. When you stuck elephant into the buffer, it will really stuck inside, right? It will hold all the mice, which are interactive small flows, like voice over IP, like what we or video conferencing, what we are doing right now, or gaming, online gaming, streaming, YouTube, Netflix, and so on, or signal call, right? So then these mice can go through the buffer, because the big flow is stuck inside. And so we need to come up, or the industry came up with the solutions to these stacking or overflowing buffers. And the solutions were three: Codel, FQCodel, and Cake, right? So like we after that, there was industry coming with more and more additional potential solutions to these issues. So these algorithms are well known, open source. Some of them are also in RFCs. So and Cake has a scientific paper, and it's proven. It's used by billions of devices already, but it's like not all the 30-something billion of Wi-Fi devices out there, and like let alone other like radios on the tower in fixed wireless, 5G, which should be really fixed because it's really terrible. Like for example, just to give people a perspective, Starlink as a satellite internet has better latencies than most of the internet service providers, and by the same token, every Wi-Fi hotspot you will ever find in hospitality, for example, or in your office. So like we have so much work to do, but the good thing is that these tools are here, and we can help people and companies, vendors and ISPs to use them properly.
It's amazing to look at the statement saying that Starlink has better latencies compared to ISPs.
So it's really simple. It's because of FQCodel. This is the magic. Like when Starlink started, they did a grave mistake. They picked the wrong OpenWRT kernel. So there was a two at the time. One was having FQCodel in it, the other didn't. So they picked the old one. And then it took some 3 years of Dave Taht, like even meeting with Elon Musk in person, basically to persuade the company to fix this grave issue. But they did, and right now they are amazing. Like when you are flying with an airliner using Starlink compared to Panasonic Avionics or Anuvu or any other satellite providers, but Starlink is hands down the best. And it's amazing. There are people in especially global South that are basing their ISP on Starlink. The other thing is like you might have like cruise ship company with 7.5 thousand people on board, and thousands of Wi-Fi access points everywhere, and it's a Wi-Fi trap, right? And with Starlink, up to 20 terminals from Starlink, and for example, quality of experience middle boxes as ours, LibreQoS, or one of our competitors, Backwind. You can make the Wi-Fi based on 20 Starlinks and really good access points, like mostly enterprise, right? In this type of setup, you can make this work, and you can have Zoom calls. You can have like pretty much anything. You can do gaming even when you pay. Obviously, it's not cheap, but you pay and you can do this happen. The same is true for aircraft. So it's amazing tech. And let me shout out Amazon Leo, like formerly known as Project Kuiper. They are also finally they said that they are promising 1 gigabit upload. Sorry, 1 gigabit download, 400 megabits upload, which is like, it's crazy, right? If they would be able to deliver something like that. But they also said that they are aware of latency, buffer bloat, and jitter, and they are looking for the right algorithm to fix it. So like fingers crossed to Amazon to actually get it done, and Starlink will have another good competitor, and in this way it will force everybody to get better. So this is something what we are looking for as a consumers.
Absolutely. In a good competition, end of the day, the customer wins.
Yes. Hopefully, if there is not a cartel and they don't want to do it, but that's another story.
Right. So this is about buffer bloat, but for an end user, he might not understand what buffer bloat is, how the technology works. So if there is buffer bloat in the network, how can that affect the end user? How can he sense there is a buffer bloat in his network? Any symptoms?
Right. For example, so many things that we see as a Wi-Fi or internet issue is basically a hidden manifestation or hidden manifestation of buffer bloat. Even there's a really simple thing that when you have Facebook or any other social media and you want to hit the like button, the time difference between like you hitting the like button and actually showing the app till the app really show you that there is a like that you gave to something. The manifestation of it, this is the buffer bloat. The underlying issue is buffer bloat. It's not. It's if there is no an app issue, or if there is no issue with your OS system on your phone or on your laptop or on your any other device, then the underlying cause of this discrepancy between you hitting the like and actually giving the like to the specific post. So this is really the simplest. The other thing is that if we would be having a call like we are having right now, you will see my lips moving basically, but there will be a delay between my voice coming to your headphones. And again, there is a lot of things in the chain, right, between two of us, and we are far away from each other. You are in India and I'm in Czech Republic, in Central Europe. Like, so there is a lot of things in play, but the delay will be visible, right? So there is a lot of things like that. The other thing that it was like a really big thing that I can mention, and people will register that because they read about it or heard about it, is the whole net neutrality debate. People were looking for solution when there was a huge increase in the use of torrents. So it was really overwhelming the buffers. Like in the end, it was overwhelming these big files, these elephants, these flows, these packets were really overwhelming buffers. And so people were looking for solutions. So they wanted to basically ban torrents. So ISPs were doing their part, regulators were doing their part, the big telco was doing their part, and the underlying issue was that we needed to find a way how to do it. It was the politicians wanted to make it political, as a political issue, especially in the US. But it was underlying cause was the buffer bloat. We needed to fix the buffers, and then you can basically download any or upload anything you want, really. But and still you can have a Zoom call during the torrent download and upload. So at least these are like really visible things that people can experience nowadays.
Right. And with regards to how worst the situations can get when with the buffer bloat, can you give us a number of the worst delay that you have seen in a network?
It can be 10 seconds, right? So when we measure buffer bloat, when we measure latency in general, right, as the symptom that's really visible, or jitter. So we see all the speed tests nowadays to show the measurement in milliseconds. If I'm not mistaken, 1 second is 1,000 milliseconds. And so you can have up to 10 or maybe even more, 10,000 milliseconds shown in the speed test. Mostly it's not the median, it's highs, right? So good speed tests these days that are really focusing to show buffer bloat as an issue, they're trying to show lows and highs, right, for any specific unloaded latency on the network, loaded download and loaded upload. And so you can see sometimes the median is like in 5,000 milliseconds, but when median is 5,000 milliseconds, the actual height can be way over 10,000 milliseconds. So that can be 10 seconds, which is like horrible. It's unbelievable. Even like to have a Zoom call with 200 milliseconds latency, it can be terrible.
Right, and with 10 seconds of latency, it is just unacceptable.
It's unbelievable, but yet people will advise, even the experts in our field will say, you need to have a higher package of the internet. You need to buy faster internet, which is really sad.
Right. Now, let's talk about the testing perspective. So for anybody who is testing to identify if there are traces of buffer bloat, so are there any specific patterns or behaviors that are clear indicators?
Look, I would always so testing, like there is a lot of opinions about speed tests, right? Because they tend, or they should saturate the link, right? So I don't test if I don't, for example, if I'm not trying to really test the network, I'm like flying with a airliner, and there is a chance to have the internet. So this is just a pure gig in me trying to find out, right? When we would be having a Zoom call, for example, and I will be able to see the lag, then I will decide and test, right? So there are really different approaches to doing it. When I see as a geek and as a consumer, when I see an issue, I'm trying to test, right? And I can do ping tool, I can do iPerf tool, I can do other like LibreQoS Bufferbloat test, I can do UCLA, which is the most famous speed test in the world. I can do waveform Bufferbloat test, which was another important thing. So I test when I see the issue. Like, I'm not the Wi-Fi engineer. I'm not setting up Wi-Fi's. I'm setting up Wi-Fi networks for my friends. So that's the thing where I, like, when I really go and really geek out and test. But other than that, like, if you see an issue, you want to find out. So I would suggest you as a consumer to do a testing. Like, when you are a Wi-Fi engineer, like, you need to use the tools. You need to do pretty much anything. You should have a hardware tool as well, right? You need to focus on the signal strength and the coverage of the specific area where the Wi-Fi is set up. So that's a different level of problems. So I would distinguish the consumer, which someone like me for the most part, and then someone like you guys at Candela, and the variety of tools that you have.
Right. So now tell us about the state of public Wi-Fi, the enterprise routers that are being set up across many places. So is buffer bloat a big headache there? Are smart queue management techniques being implemented? Give us your take.
Yeah, I sadly it's not, right. It's a really huge issue with public Wi-Fi everywhere, with the like the Wi-Fi. As the founder of Candela at one of the interviews here on the podcast said that Wi-Fi basically started for the homes, right, for the general public. Later on it was adopted by the enterprise, and typically the things are like you have many I would say progressive features in the home Wi-Fi's that are like just later on finding ways or inroads into the enterprise access points and Wi-Fi points. And obviously there is a difference in a workload that and complexity that enterprise Wi-Fi needs to carry. And typically you might have dozens or even hundreds of people connected to the enterprise Wi-Fi. So way more issues with telemetry, with triangulations and everything. But the general solutions to Bufferbloat, FQ-Codel and Cake didn't make inroads into the enterprise access points for many reasons. If the companies worldwide would adopt FQ-Codel and Cake in the past, Wi-Fi 5 would be more than enough for the consumers all around the world for the years to come. And I would be, willing to sit down with any expert from the industry and discuss this topic further. So there are technical issues that are preventing enterprise Wi-Fi routers, access points, and so on in adopting these solutions. But there are also other, say, business or whatever reasons that they are reluctant to do it. The consumer market is different because you have a tremendous pressure from gamers in the past, and right now actually from everybody that's actually experiencing these issues at home or in a coffee shops and other public places. So there is a pressure from various parts of the world.
Right. So you talked about FQ-Codel and Cake techniques. So how are these techniques helping to reduce the buffer bloat, and how good is the adoption in the industry worldwide?
So as for the adoption, these two are in mainline Linux as well as in OpenWRT, DDVRT, and basically any other derivative of OpenWRT. And so many routers, so many devices are based on Linux or on OpenWRT and these derivatives. So Starlink, as we said, was based on OpenWRT. So but even then, when the product is based on Linux or OpenWRT or many other derivatives of these amazing open source solutions, not in every situation the vendor actually turn on these features, right? Or give people a chance to turn on FQ-Codel or Cake. So it's adopted by many vendors. From the mainstream vendors, I would like to say MikroTik, which is not open source, but they were the very first mainstream company that actually adopted FQ-Codel and Cake. From then there is many companies that are selling OpenWRT routers or any other derivative of these routers, like GLINet, for example. And Turis, the company that I was working with in the past. And there is like the other companies that are doing it. For example, Aero, another brand from Amazon, and Firewall, for example, firewall that you will plug in your network. And also like the latest addition this year, like really important, was Alta Labs, which was founded by former Ubiquiti Networks people. Ubiquiti has some form of implementation of FQCodel, but it's not done right. It's not full FQCodel implementation. And as for the two, there are differences in performance between FQCodel and Cake, and FQCodel was slight improvement on Codel, which was at the time probably 5 years old, and it's about smart queue and active queue management. So it's really working with queuing, right? So you have your buffer, and it's really helping the clear the buffer and get it ready for other flows coming in. And Cake is more CPU sensitive, so you need to have a powerful machine, powerful CPU in your router or other equipment to actually run Cake. But right now there are like improvements on Cake at work. One of them is MQ Cake, and it is done by Toke Hoyland Jorgensen. He's the guy that actually wrote this amazing book, Bufferbloat and Beyond, and it will appear in the show note. And people can get this book for free, and it's like full of everything that people needs to learn about Bufferbloat. They will ship it. The University of Karlstad, they will ship it anywhere in the world, and everybody can request 2 physical copies. They can download unlimited PDFs. And there is a wealth of knowledge about this topic, and I would highly recommend like everybody in the internet industry to read the book.
Right. Thank you for the book recommendation, Frank. And now let's get back to the users again. So many of the users, they do run speed tests to check their internet connectivity. So are there any speed test recommendations that you would suggest which highlight the issue of buffer bloat?
Right. So the probably the first speed test that really showed buffer bloat as a really important issue on the internet. Wave in the ocean, yes, wave form buffer bloat. So they were really trying to show this issue. Then UCLA speed test that everybody knows. They started to show latency, and actually they were probably the first that showed highs and lows for latency under load, which was like really important addition. And then there is a new test that started this year from the founders of, or one of the founder of UCLA, and it's called orb.net. Their methodology is different. They are trying to keep the connection with every device on the network, and they are doing basically something that I would call a health check on the device. They have in their suite, they have also like a regular speed test, and Dave was giving them feedback during the development. And there is also like a LibreQoS Bufferbloat test, and like we were trying to do our best in order to address like all the issues that Dave was raising over the years, and showing the speed tests of the world, how to get better. So Bufferbloat LibreQoS test is also one of these that I like to use.
Right. Going back to our initial question, so people who just say add more bandwidth. So for the users who need to understand why latency is a very critical aspect to look into the network, so what role does latency have in an end user's experience?
Basically the whole, right? Everything that we are, almost everything what we are doing right now is latency sensitive. It's interactive. We see with the inception of applications like VR and AR and pretty much anything that we can't even imagine, right? It will be latency sensitive. If people are talking about self-driving cars, it will be just the latency. You would need to have internet connection, absolutely. But like, we know when we are driving or when we are doing like anything similar to driving or flying, like we know that how really intensive on the really small changes of pretty much anything that's happening in our vicinity and our reactions to it, how really dependent on this kind of stuff it is. And when anything is online, these sudden changes that you would need to accommodate to, it won't be, you will have the physical connectivity, but it will be really interactive. It will be dependent on other stuff, like even like besides, like what's the question is, like, what's not actually interactive on the internet nowadays? Like maybe sending an email, that's not interactive when we are really downloading or uploading the file. But other than that, like we came up to realization that even something like when you are doing SAP migration, you are migrating servers for SAP, like used by probably billions of people in big factories all around the world, and you are doing the migration. You realize that you are migrating like terabytes of data. However, like SAP needs to get some of these data to the other server sooner than the bulk of data. But how you can clear the buffers to get this information sooner to the place, because it will really improve the future go to life of the new server.
Let's say if I understood the importance of fixing buffer bloat, and I got it fixed on my router that is at my home, but you are many hops away from me, right? So between you and me, there might be tens of nodes sitting in between, many middle boxes. So how important is it to fix across the network path so that the end-to-end latency is as per the expectation?
It's really important, and therefore like we will be working on it basically till the end of our lives for many different reasons. And so if we want to divide the whole internet into simple parts, there is last feet or last meter, last mile, which is both of them are basically an ISP territory. And then there is a middle mile, and there is like the rest of the transport of by cables basically between the continents, more or less. And so like you said, there is many hops, right? So we are trying to fix every single one of them, or we should be trying to fix every one of them. And why? The answer is simple. There is a buffer on every hop. Right, so to really make it simple, there is a buffer on every hop, and we ideally would have algorithm like FQ, Codel, or Cake or on every single buffer, and we will be building or we will be manufacturing routers or any other networking equipment with this in mind, and we won't be afraid of packet drop. And we would really we would see it as a signal to send again, and to send in different pace. And basically, so there is various issues on physical layer with the connectivity, with the radio frequency, with the Wi-Fi traps, with pretty much anything that can annoy our experience. But then there is these buffers, and we need to solve the buffers everywhere. Then we need to do additional stuff. Like, it's not easy, right? So we need more peering. ISP should peer more. Almost every ISP should start an internet exchange point. But that's the other thing. Then there are CDNs. Like, ISPs, if they can, should connect to the CDN, right? And so it's like they need to think about topology, right? So topology and network provisioning, like of all the equipment that you have under your control, is really important to get it right. Then when we are speaking with the network engineers, Wi-Fi engineers that are setting up the Wi-Fi, they need to start to look beyond radio frequency. Most of the time, they are looking at the signal. Is there a signal strength? Can I basically blanket the space with the signal? Can I take care of the proper handover between the access points? All the important issues. It's a physical layer. We need to get it done. It must be right. But then again, we need to take a look beyond that, and we need to think about the actual customer experience, which is almost 100% about the latency. Yes, you might have a terrible captive portal that will allow you to join the Wi-Fi, but that's something that's I would still call more physical layer than actual experience, because once you are connected, it's about the actual latency, because almost everything is latency that we will be experiencing nowadays. So like 2025, I would like to give a shout out to Wi-Fi engineers. It's the very first year that I on LinkedIn and on Twitter X, I can see really people from the circles of Wi-Fi Now, Virus LAN professional community, and like WICO events, and basically it's the very first year when Wi-Fi engineers started to talk about the latency. So it really it makes me happy so much, because I see them, people that I was meeting on Wi-Fi events and open source events for years, and they were like always telling me that latency, it's an ISP thing, it's a broadband thing. And I was like, no, man, I'm like connected to your access points here, and it's terrible. And they were like, no, it's not us. And I was literally like angry, and I was like trying to get the point across the table. But 2025, let's mark it as the year when Wi-Fi engineers really started to notice, and they started to explore this topic. So I'm like, it's really promising for the next year.
Absolutely. And as you said, it's important to fix buffer bloat on every node, because even one single node across the path, which has a very bad latency experience, it can get down the user experience.
Yes.
Even one node, right?
Yes, it's really that's sad, because it will be the bottleneck. It's always like that. The lowest denominator, it will create the issue.
Right. Now, let us look at what is the state of industry currently. So, what is the industry doing collectively as a whole to fix buffer bloat? And are there any standard bodies or vendors that are trying to push in fixing buffer bloat issues?
Right. So, like, I don't want to come across as pessimistic in terms of talking about the industry bodies and alliances and so on, but sadly, it's like that. It's really not enough. They are not doing right things. They are pushing things that are not good enough. And like just a couple of days, there was a Wi-Fi Alliance announcement about their new draft of something that they called quality of service, right? But when you look into it, there is nothing about like really fixing the buffers, really fixing the buffer bloat. They're trying to do some prioritization for voice and video and so on, but this is not the real deal, right? In IETF, I've been lucky to be a couple of IETF meetings, and currently the only big thing that was going through the IETF in the last couple of years was L4S. It's pushed or championed rather by a couple of big companies like Comcast in the US, Apple, and Cable Labs, and some others. And like from my point of view, as well as from Dave's, it was not the right solution. There was quite a big opposition raising the points why it's not good enough, why it's not the state of the art.
Yeah, so now I would like to know about what's your future anticipation on buffer bloat with things like AR, VR getting mainstream, and also Wi-Fi 7 and 8 are coming into picture. And also sometimes people are also talking about real-time actions with robotics and all. So do you see buffer bloat getting solved in the near future? What's your take on that?
Like right now we have even big companies that are trying to focus on that, like even though they might not be using the best tools, in my opinion, like L4S, but they are trying to do to really improve. And it, like, don't get me wrong, like L4S is obviously an improvement compared to like old Doxy Spy and similar algorithms, or no algorithms, or FIFO, like first in first out, right? It was, it was terrible. And like this will be improvement. It will improve stuff in Doxys. It's supposed to improve the latency on 5G, for example, and so it will get better. And even and also the notion of throwing bandwidth on everything, it will decline. It still will be sadly used by many as an argument, or you need more bandwidth, everybody needs to have a 10 gigabit at home or something like that. So like these two things will be happening in parallel. Basically, you still will be having the old approach. You will be there will be L4S and others trying to solve the issue, and then basically along the way there will be us, like all the meter boxes, because like we understood that the idea of fixing every single hop, it's almost undoable. Like it would cost like trillions of dollars. It's really, sometimes it's like it's you can't do that even in a timely manner. So basically, like if we would really want to fix the buffer bloat, many people will be doing their thing, like L4S will be doing their thing. There will be more and more OpenWRT routers. There will be more and more companies that build a router on any other network equipment on Linux or on top of OpenWRT, and they will be like enabling. They will be enabling FQCodel and Cake. There will be new companies adding Cake or FQCodel. There will be these improvements for Cake. And besides Toki and MQ Cake, there is Jonathan Morton, one of the principal authors of Cake, working on his new Q discipline, and like he is a genius. So there are like expectations that it will really fix some of the issues, like inherent in Cake. For example, there is Cake Auto Rate. Cake Auto Rate as a solution was built because 5G was really, really terrible. And when you speak with 5G people, they will say, like, there is no latency. And even though you show them a speed test when there is a 5 seconds of latency and one gigabit, that's crazy. You might have a 5 seconds of latency and 1 gigabit throughput, speed, bandwidth, right, whatever. Right. So this is the thing. So all the things will be happening in parallel. But if there is something that will really make a dent in the ISP world, in the last mile, basically last mile and last feet, last meter, it will be meter boxes. Meter boxes will be everywhere. Now they are starting to be on cruise ships. There are campuses on universities, and they will need to have a meter box. It won't be feasible for them to change all the routers. Like all the like remote stuff. When you will be doing like a mining, for example, mining will be done more and more remotely. So people will need to have a latency and, for example, latency fixed. And so meter box, it will be the like the policeman that you will drop into your network, and he will help basically clean the buffers, clear the buffers rather, and basically to take to help the traffic to flow, right? So the middle boxes will be everywhere, not just in ISP networks, but also like in big offices. You will need to have a middle box because it will be impossible to just change all the routers and so on. And also like other devices like this, like Apple was adding the L4S, right? So it will really improve stuff for Apple devices. But then we have Android, and we need to fix Android. Then we have additional stuff like inherent latency in the applications. So applications like Chrome, right? Chrome has latency issues. So Google should work on that and improve the situation. So there is a lot of things that will be happening in parallel. Like I am like really hopeful for the future, and I do believe that we will make a dent into this issue, but it's really slow.
Yeah, and that's frustrating.
Yeah, it's painful. Like when you are working on it, and when you see people like Dave and Jim Geddes and Toki Hoyon Jorgensen, Jonathan Morton, Fan Jacobson, Caitlin Nichols, and many amazing people that are doing their part, and yet like we barely make a dent. I will give you one number if I can. So currently, only 4%. 1 digit, 4% of internet service providers in the world are using some quality of experience middle box on their network. It's really not enough. And even though it means that a couple of billion of people are using or are experiencing better internet because of middle boxes, it's still nothing compared to the rest of like 6 billion people.
Right. So I think we are done with all of our questions. So before concluding, if you would like to quickly address our audience anything on Bufferbloat, please do. Then we can conclude.
Absolutely. So I would say that you people at homes or in the offices, if you can change some of the things that are going on in the office, get a better router. And better doesn't mean more expensive, because like a really good $20 router that can run OpenWRT can really fix most of your issues. Like you can't in many situations control your ISP. You can ask your ISP to get better, but at least your last meter or your last feed will be good. Then you can always learn more about the topic. Like if you are a network engineer, especially, or if you're an ISP, please join like Bufferbloat mailing lists. I will provide the links to the show notes. Order the book, that's for free, right? And they will ship it to you anywhere in the world, and you will read it, Bufferbloat and beyond, and you will really learn a lot about the topic. And continue informing people that can change these things, that change is really needed, and this issue is still prevalent in the world, and it will be even more impactful, or negatively impactful in the coming years because everything will be latency sensitive.
Absolutely. Thank you so much, Frank, for joining us and sharing all this wisdom with our audience. I hope they take very good insights about how important it is to fix latency in the network to have good end user experience. Yeah. Thank you so much for joining. And for audience, if you like the episode, please like, share, subscribe, and continue watching Weekly Wi-Fi Wisdom. And we'll see you guys in the next episode. Thank you so much for watching, and thank you for giving your time. Thank you so much.
Thank you very much, Sainat and Candela.